I am going to just warn you guys, during the course of today's notes, we'll be going out in the hallway for a quick field trip, all right, to demonstrate one of these concepts today. All right, little field trip out to the hallway. You know how to reflect, you know how to translate, and you know how to rotate now. What if I can do 2 at a time? That's what I'm going to ask you to do today, 2 at a time. All right. First thing, there's a little typo on your notes. It says composition symbol for transformations. Can you just cross that out and rewrite symbol for compositions? Here's what a composition is: 2 or more at a time. So you rotate, then you reflect. You translate, then you reflect. All right, 2 at a time we're doing. How do I know one of these compositions is going on? And you can kind of see the symbol down below on your packet. You see this little degree symbol. All right, that's what tells me a composition is going on. You'll see that little degree symbol. And let me give you an example of a composition you're going to handle here. Give me a transformation we've done. Rotate. Okay, give me a degree measure. Okay, rotation of 90. There's that little composition symbol. Give me another transformation we've covered. Okay, translation. I'll put the capital T here. And what do you want to translate? 3, -5. And we need to do it on a point. So anybody want to give me a point? There we go. Boom. Could I have added more compositions to this? Yes, it doesn't have to be 2. Could be 3, 4, 5. Who knows how many? I have a question right off the bat. Anybody? You know you're going to rotate and you know you're going to translate, but what's the question? I would have, definitely. Which way? Which goes first, right? It's going to matter. Do I rotate or do I translate first? Here's how we read compositions, and it's going to be a little bit different for you. They are done right to left. All right, these compositions are done right to left. So if we were to perform this, we're not going to, but which one out of the two there, the rotation and the translation, I would do what first? So I would translate 3, -5 on 7, 2. Whatever my new point is, then I keep going to the left and I would rotate that point 90. Okay? And then if there's another one, I keep going to the left till I finish. All right, so I would take 7, 2, translate it 3, -5, take that new point and rotate it 90. That's how these compositions are read. All good. All right, a couple little facts about compositions. What if I wanted you to reflect across 2 parallel lines? All right, let's watch the magic happen here. First off, I put this in notation for you so we can practice. Which line am I going to ask you to reflect over first? Number 3, which line is all the way to the right? L. So everyone right now, best of your ability, I'm not going to be critical on you, take this B, capital B, and reflect it over line L. Again, that's the one to the right of the composition, so that's what I'm going to do first. So go ahead and reflect that over line L to your best of your ability. Not looking for greatness or a compass or a straight edge here. Oh boy, that's disgusting. I'm keeping it. And then keep going to the left. I'm going to take that B and do what with it? 25? Keep going. Watch your map. What? No, right here. Don't look at the one example I gave. Right here, under this one right here. So I reflected it over line L. Keep going to the left, Allie. Okay, everyone go ahead. Take your B and reflect it over line M now. Not the original one, the one you just made over line L. So that's where I end up. Here's the challenge question for you now. What could I have done beginning to get to that last B? What single transformation could I have performed to go from this B to this B? What single transformation could I have done to go from this B to this B? 10? Sure, you got it. What single transformation, because I did two of them. I did two reflections. What single transformation could I have done to go from this B to this to get here? Just a translation. And that is true for every time you reflect over two. What type of lines are these? Parallel lines. Anytime you reflect over two parallel lines, it is the same as doing a translation. All right. Anytime you reflect over two parallel lines, same as a translation. Are my lines always going to be parallel? What other type of lines do I have? If they don't touch, if they don't intersect, they will intersect, right? So what happens when I do this over two intersecting lines? Let's find out. So now L and M are not parallel anymore, they intersect. Is that going to still lead in a translation? Let's find out. First thing, 11. Oh, one job. 30. According to this composition, which line am I going to reflect over first? Okay, everyone, go ahead. Draw your C after you reflect over line L. Will this result in a translation again at the end? So reflect it over line L, boom. And then take that C and reflect it over which line? 21? Line M. This might be tough for some of you. Try to fold your paper over if you need to see where that C is going to look like on the other side of M. Now, again, not going to be critical of you. I just want you to get the idea. So it doesn't look like I translated it, did I? To go from the original C to this ending C, what single transformation happened there? 3? What single transformation to go from this beginning C to this ending one? Rotation. Yep. All right, everybody good? Rotation. And I just want to show you where we would use this. What's the most famous pair of intersecting lines we deal with? Okay, perpendicular. Well, what specifically? Most famous pair of intersecting lines we deal with. Go ahead, Ella. The X and Y axes. Right? Everyone agree? So if you're ever asked to okay, ready? If you're ever asked to reflect a figure through the X and the Y, that's the same as doing what to it? Rotating it. Okay? It should be a rotation from the beginning. All right, any issues with if the lines intersect or if they are parallel? Because we are going on a little field trip now. There is one other type of composition I need you to be aware of, which is called a glide reflection. What's it sound, the glide sound like we're going to do? Translate and reflection, obviously we're going to reflect. So this is going to be a reflection and a slide. All right, a reflection and a slide, but you can't just slide anywhere you want. Let's go out to the hallway real quick. Going to need some volunteers when we go up there. dance move. Reflect and slide, or slide and reflect, all right? It's a dance move. You can put a little shoulder action into it. All right, whatever the next upcoming dance is. I don't know if there's any more left in the year, but all right, you can try out the glide reflection on the dance floor. Everyone good? Glide reflection. Slide, reflect, but the slide's got to be parallel to what you reflected over. All right? All right, now let's actually try a full scale composition for me. So I have this triangle text. Go ahead, you can graph text. We see the symbol right here. We see the composition symbol. So I'm thinking right to left, right to left. So with T, E, and X, what's the first transformation you're going to perform on them? Number 26. If I'm reading this right to left, first one, what am I going to do with those coordinates first? Translate it 0 on the X and -5 on the Y. So go ahead, everybody. Perform that translation for me and get T prime, E prime, X prime for me. So perform the translation first. You're not going to move on the X-axis, but you are going to move down 5. How about down 5? And then from here, keep reading to the left. You're going to take your prime triangle and 27. Where are we going from here? Reflected over the y-axis. Those are the coordinates I'm interested in here at the end. And I'll have some of those coordinates for me. "17, when you're ready, what are those ending coordinates? T double prime. I think that's X, isn't it? X double prime, 2, -4. Go ahead, any of the other two? Yep, finisher now. All right. Any issues there? Right to left, not a big deal. If you had to rotate, maybe that might be a big deal. Questions before I go into a kind of a brand new vocabulary topic now? Okay, this concept of orientation. Here you go, triangle. And just take a look up here, right? Triangle ABC. 10, big job here. Name the vertices in any order you want. What is it? Original. Good. What direction are those vertices going in if I go to ABC? Clockwise. All right. That is called the orientation. All right. When I go from A to B to C, that is in a clockwise orientation. All right. So when we're asked about orientation, I'm specifically asking for the order, or excuse me, direction of the vertices. Of a figure. Now, could we have gone in a different direction? It would have been counterclockwise, sure, but ABC is where we're sticking from now on. All right, we're not picking a different sequence of letters. It's going to be ABC. So here's what I want to know right now. We've done how many different transformations? How many different transformations have we done? What have we done? We've done a translation, rotation, and a reflection. All right. Let's start with translation first. If I translated this triangle that I had up here and went ABC again, would it still be going clockwise? So if I slide this figure up, down, left, and right, anywhere I want, and then did ABC again, would they still be going clockwise? Yes, no? Yes, they would. So because they still would be going clockwise, we consider a translation. Why do we consider it a rigid motion? Shape and size doesn't change with same orientation, because we said if we went ABC, it would still be clockwise. So a translation would be a rigid motion with the same orientation. All right, let's keep thinking. This might be a little bit more challenging. How about my rotation? If I rotated a figure, or in this case, if I rotated triangle ABC, turned it 90, 270, 180, whatever, and went ABC again, would I still be going clockwise? Yes, no, maybe? Yes, we would. Yes. It would not change that orientation. So we can also add to this list rotation. Let's go to this next one. Reflection. If I reflected the figure and went ABC, would I still be going clockwise? Well, let's take a gander here. I'll just do this random line here. I know, very professional. Let's say I reflected it over this line. Here's B prime. What's this one? C prime, and this one is? All right, let me go Maggie's ABC again. What direction do you see? Counterclockwise, so the orientation changes. So we're going to put it over here now. It's a rigid motion that has opposite orientation. Okay, here's the thing though, because we have some blanks. Not good enough. Not, you guys don't understand why yet, but not good enough, just a reflection. What are the only things I've asked you to reflect over? X and Y axes, right? Y equals X, they're all what? Lines, lines. So I need you to adjust this for me. Line reflections will produce an opposite. Well, what else could you reflect over? Tomorrow, we're going to start reflecting through points. And you'll notice the orientation does not change when we reflect through a point. So that's why there's a number 3 over here. Point reflection. When you reflect through a point, orientation does not change, but with a line it does. And then there's still a number 2 there. And people are like, oh, it's got to be dilation. We haven't talked about that yet. Well, I don't think so. Why am I not putting dilation anywhere near this? It's not a rigid motion, but there is one more left. Emma? Glide reflection? What do you do? What do you do with a reflection? You were in the glide reflection. You reflected over where, Meg? A line, right? You always reflect over a line. So yes, glide reflection as well, because you end up reflecting over a line. Okay, so everyone all right on orientation? You decide on the order you want to go first. Keep that order consistent and see if it goes from clockwise to counterclockwise or remains the same. And the final thing you're going to do in your groups today, I am going to give you one figure to the other. What did I do? Did I reflect, rotate, translate, or this new glide reflection? All right, so you can discuss it within your groups. I'll give you a few minutes from A, B, C, D to G, H, C, D. What did I do to get there? Did I reflect, rotate, translate, or glide? On this one. Let's start A, B, C, D to G, H, C, D. What am I doing here? 12. What am I doing here? That is a reflection. Perfect. Ask away at the end here if you have any comments. Looks like number 3, G, H, H, G, J, I. That's a mouthful. L, M, J, K. 25. Rotation. Great job. Had to be on your game for the next one. 9. Glide reflection. Is that what we're just calling shorthanding it now? The gold glide? Glide reflection. Thanks, Maggie. And then the finisher. 16. Translation. All 3 brought up here. All right, a real quick comment before you head out to your packet, which is the homework tonight. Take a look at number 1 for me. I threw a dilation in there, even though we have yet to discuss it. So just let me talk to you real quick. On number 1 for the homework, you're asked to do this composition. You read them right to left, so which one are you going to do first? The dilation. How do I do a dilation? Well, whatever number, and we'll talk in great detail because that's what we're doing on Thursday, I think. That number that's with the dilation, that's what you multiply your x and y coordinate by. Okay, so that number right there is what you end up multiplying. Multiply the x and y coordinate by. All right, so you guys can get started on that. Read everything carefully. There's a couple things you have to do specifically on number 3 and number 7. Answer key up on Aspen.